Welcome to Math with Mrs. Bibb. Today we will be discussing parent functions, their equations, and their graphs. It's very, very important that you learn these parent functions as you will be using them in this class and in future classes. The first thing I want you to do is I want you to look at your paper and make sure that in class I had you guess which parent function each of these are. So the whole front of your paper, there's a line underneath there that says guess. So I want you to take the time, if we did not do that in class, and I want you to look at the words at the very, very bottom of your sheet, and I want you to put one word with each parent function graph. So take the time to do that. Now, what I'm going to do is I'm going to go through each of these and tell you the actual function family name. And what I want you to do is, let's say you guessed linear for this one. I must be writing with white. Let's say you guessed linear. And when I tell you that this is an exponential function, then just put an X there. And that's okay, we're not marking it wrong, but this is definitely not linear. It is an exponential function. And the equation of this particular exponential function is y equals 2 to the x power. What you will notice when you have an exponential function, and on the side or underneath the table, write x is an exponent. That's how you know you have an exponential function, is x is an exponent. It's not always y equals 2 to the x. You can have y equals any number raised to the x power, as long as your x is an exponent. That is an exponential function. Now I want to show you here that these ordered pairs, we're going to use y equals 2 to the x as our parent function. These ordered pairs, negative 1.5, 0, 1, and 1, 2. We're going to plot these 3 points every time we have an exponential function and draw this curve through those 3 points. So please make sure you plot those points on your paper as well. And remember that those are the 3 points we're going to use for an exponential function. Y. And then I'm going to put f of x equals 2 to the x. And somewhere near the top, maybe up there beside the word graphs, make sure that you put f of x is the same thing as y, just so you can remember that. And arrows on the end of this, because it does keep going. And this line here, this line y equals 0, that is called an asymptote. It's a line that a curve or graph approaches but never touches or crosses. So this line will actually never cross the x-axis. It approaches it, it gets closer and closer and closer, minutely closer and closer and closer, but it'll never touch it or cross it. That is called an asymptote. All right, keep going. I should have mentioned on the last slide that a parent function is the most basic function of that particular family. And I believe we defined that on another set of notes, but I just wanted to mention that again, that these parent functions are the most basic function of a function family. And again, make sure you check to see if your guess is correct. If it's correct, put a check mark. If it's incorrect, put an X. And this is actually called a constant function. A lot of students will write line for this one, which is true. This is a linear graph. It is a linear function, but it is best named a constant function. And the equation for this particular constant function is y equals 2. As long as y equals a number, no matter what that number is, then that is a constant function. You will notice that there's no x in a constant function's equation. That means that the slope is 0 when you have a constant function. So a constant function, the slope is 0. And we're going to plot those points that I have in that list. So I have -1, +2, 0, 2, 1, 2. And if you will notice that you will have whatever this number is, that's what will be here. -1, 0, 1, those won't change, but whatever your number is, that will be in the y column, y equals 2 in our case. So whatever y equals, that's a constant function as long as you don't have an x, and that means your slope is 0. And a line that has a slope of 0 is a horizontal line. So please make sure you have all of that written down underneath the table. I'm going to put f of x equals y. Excuse me, f of x equals 2. F of x does equal. And I'm going to put arrows on the end of this, so make sure you have arrows. For the next one, whatever you guessed, please again make sure you mark it. If it's correct, put a check mark. Hopefully everybody got this one. We've talked about this one. Now, and remember specifically, this one is a parabola. It's called a quadratic. It's specifically a parabola. There are other quadratics. That's why there's prefix 4. And those other quadratics we'll talk about another day. And one of my classes, I know I did actually show you the cone and talk about those other quadratics. But this is in the function family quadratic. And the equation for this particular quadratic is y equals x squared. I should have made sure to write f of x equals x squared. That's probably how we're going to see these more often. I'm going to go back. I'm going to plot those ordered pairs. -1, 1, 0, 0, 1, 1. And then you'll draw that U shape. Remember, these do keep going. I use Desmos to draw these graphs. As you can tell at the bottom, I made sure to include that Desmos was used to create those graphs. But those graphs continue forever on there. We need to make sure that we have arrows on our graphs. I'm going to go back again. The next one, I'm going to put arrows on the end just so I don't have to go back. Hopefully your guess was linear, so make sure you check it or X your guess. And then this is a linear function. It belongs in the linear family. The equation is f of x equals x. And I'm going to just use f of x from here on out. That way we don't have to go back and put or. And then I'm going to plot those points. -1, -1, 0, 0, 1, 1. That is a linear function. Belongs to the linear family. Next, this one is a logarithmic function. It is very similar to an exponential function. An exponential function, the line y equals 0 is an asymptote, but here, for a logarithmic function, the line x equals 0 is its asymptote. So it approaches a vertical asymptote, whereas an exponential function approaches a horizontal asymptote. And again, check or correct this one, or check or exit to see if you got it correct. And our logarithmic function, I was about to write y equals, our logarithmic function is easy to recognize. Y equals log x. It actually has the word log in it. That's why you see that button on a calculator that says log. It doesn't literally mean a chunk of wood. It does mean logarithm. Explain something. I want to go back here. Do you see that where it says ERR? That means anytime you see that in a table, that means that that graph actually has no value at that. That's how you know. Another reason you know when you look at a table is if it says error, that means that that curve never goes to 0. If you could see the whole entire table for this, at -1 it would also say error. At -2 it would say error. This line actually this curve actually approaches the line x equals 0, but it will never touch it, as proven by this, or cross it. So when you see that ERR, that just means error. That means that curve or line doesn't even go there. No, I did not. So make sure you put your arrows. I did not. So 1, 0, which that was plotted, and then 2.3. And of course we have that 0 error. So we'll draw a curve through those points, a curve that approaches but doesn't touch or cross. Oh, I think I need the next one. Hopefully you guessed correctly. If you did, check it. If you didn't, put an X. And this is from the absolute value family. Absolute value looks like a V. That's what you'll hear me say pretty often. Absolute value looks like a V. It does keep going. Did I draw the arrows on the last one? And the equation for absolute value, f of x equals the absolute value of x. And the ordered pairs plot -1, 1, 0, 0, 1, 1. I don't think I plotted the ordered pairs on the previous one. Y-axis. Ready for the next one? This one is, you'll hear me call it a rational. Make sure you check or X your guess. Or reciprocal. It depends on what day that I'm talking about it. It's either one of those, a rational or a reciprocal function. So whichever one you want to use is perfectly fine. F of x equals 1 over x. So a rational or reciprocal function. And then we're only going to plot 2 dots. We're going to plot 1, 1, and -1, -1. And in this circumstance, the line x equals 0 and the line y equals 0 are asymptotes. So those curves that you see there, they are curves. Those curves will approach the vertical x equals 0 and the horizontal y equals 0, but never touch it or cross it. And put arrows on the end. I was about to forget because they do keep going. And this one, check or X your guess. This one is a cubic function, and f of x equals x cubed is my equation. F of x equals x cubed. Then I'm going to plot these 3 points, -1, -1, 0, 0, 1, 1, and then draw a curve that looks like that through those 3 points. The last one, and check or X your guess, and it's okay no matter if you got it correct or not, just make sure you check it or X it. And then we're going to call this one its name, which is a square root function. The equation of a square root function I think is easy to notice. F of x equals the square root of x, and it actually does stop here and keeps going here. So 0, 0, 1, 1, 4, 1, 2, 3, 4, 2. Those are the 3 ordered pairs we're going to use to graph a square root function. Next, we are going to actually graph y equals x cubed, y equals absolute value of x, y equals x squared. Oh, and y equals x squared is repeated. Hold on. Let's just make that y equals x. So on your paper, if you'll just make that y equals x. At some point, you will have these memorized. First of all, this is a cubic function because it's y equals x cubed. The ordered pairs, they're on the front, so if you need to look at them, that's fine. The ordered pairs are -1, -1, 0, 0, 1, 1. And then you're going to draw the best you can the curve that looks like that parent function. That's a cubic function graph. And hopefully you can tell by the vertical bars here that this is an absolute value function. And the ordered pairs are 0, 0, 1, 1, -1, 1, and draw the best you can the graph that looks like a V. That's the absolute value function. Next, this is a quadratic function, specifically a parabola, but it belongs to the quadratic family. The ordered pairs are 0, 0, -1, 1, and 1, 1. And I just said the same exact ordered pairs that I did for absolute value, but instead of drawing a V, you're going to draw a U shape through those points. And for my last function, that is linear, and the order pairs are -1, -1, 0, 0, 1, 1. And hopefully you recall that for the first function I did, the cubic function, that was the same order pairs, and except this line, this time you draw a straight line through those points. And my line went a little crooked, but that is okay. Next, we want to look at these equations and see if we can figure out what family it belongs to. Again, remember at the bottom of your paper is that list of the function family names. And I see one that's super easy. This is a logarithmic function because you see that word log, logarithmic. Y equals 2 to the x. X is an exponent, so that's an exponential function. Y equals 2, there's no x, so that's a constant function. 1 over x, x is in the denominator. I probably should have written that when we talked about the reciprocal or rational function. That's a reciprocal or a rational function, whichever one you want to call it. And then I think the last one is super easy too. Y equals the square root of x. That is a square root function. Next, these are graphs I actually drew myself, and they're not the greatest, and the picture quality is not the greatest, but that's okay. We will go with it. Let's first go through and name the parent functions. The U shape comes from the quadratic family. The V shape comes from the absolute value family. This that has an asymptote of x equals 0, that comes from the logarithmic family. And this one here, it doesn't quite look exactly like it, but it has a horizontal asymptote. And so that means it comes from the exponential family. The parent function equation, y equals, let me use f of x. F of x equals x squared. The parent function equation for absolute value, f of x equals the absolute value of x. The parent function equation for logarithmic, see I did it again. F of x equals log x. And the one we're going to use for the parent function for an exponential, f of x equals 2 to the x. I think I have some more on the next slide. So again, name the function family and name the equation of the parent function. So this one you see here, which is very, very light. If you need to color it in, let me, I'll use green. So this is a curve that goes here. I had a dot here and a dot here, and then this is a curve that goes here. I think you can see the second one. The third one you can see just fine, and the fourth one, that first one on the left was just a little bit light. Okay, so what family does that belong to? Well, hopefully you can see that the only parent graph that we have that has two curves is the reciprocal or the rational function. So reciprocal or rational. And the parent function's equation, f of x equals 1 divided by x. So when x is in the denominator, that is a reciprocal or rational function. Next, this one looks like the square root family. It's just been moved. And the parent function equation, f of x equals the square root of x. This next one, I know it's hard to tell, but this is the x-axis and this is the y-axis. Oh, no, it's not. I believe this is the x-axis and this is the y. And the reason why I think that is because there's arrows on the end of this. So this is your actual graph, the one down here at the bottom. And so this is a horizontal line. So this belongs to the constant family. And my equation that we have that we're using as the parent function is f of x equals 2. And the last one, that is a cubic function, and f of x equals x to the third power is the parent function. And that is all of the notes. It's very, very important that you learn these and you learn to recognize all the equations and recognize all of the graphs and be able to put them together. We will have an assessment where you have to know each of those, and you will have to know those ordered pairs that are on the front side of your notes. I hope you have a wonderful day.